Alright, in this video we're going to be finding a critical value for a given confidence interval. So first we need to define what is a critical value. A critical value is the value that a test statistic must exceed in order for your null hypothesis to be rejected. And it's denoted by our symbol right here, Z alpha over 2. So first we need to recognize that we're being asked in our A part to find the critical value Z alpha over 2 needed to construct a confidence interval with level 99.7%. So if you can remember from a couple of chapters ago, we dealt with finding Z-score. So it's similar to finding Z-score. What this level is what's in the middle of your graph. So we have a couple of steps that we need to take. Now, another thing to remember for critical value is it's always positive. So our always positive one is going to be this one right here, because we're using a standard normal curve. So for a standard normal curve, if you can remember, it's always your mean equals 0 and your standard deviation equals 1. And if we're trying to find a z-score or a critical value, remember that we're always using our inverse norm command in our calculator. Now, specifically with inverse norm, we have to have the area to the left of our value. So we need this entire area over here. Well, we're kind of missing a little bit of area, right? And we need to find that area. So remember, an entire graph is going to be equal to 1. So we can find that missing area by doing 1 minus 0.997. And because we have two areas that we're missing, one right here on our right and one right here with the question mark, we can actually divide this by 2. So let's do that quickly in our calculator over here. 1 minus 0.997 gives us 0.003, and then we want to divide that by 2, and we get 0.0015, and that's going to be our missing area right here with our question mark. So this area is 0.0015. Now again, we're trying to find this critical value right there. And that critical value, we're going to be using, again, our inverse norm command in our calculator. And we need to get the area to the left. So over on our calculator, we're going to press second vars, go down to inverse norm and press enter. Now we need to know, what is our area? Well, our area is going to be 0.997 plus that area that we just found, because we need the entire area. And then our mean and our standard deviation are going to be 0 and 1. So we're going to put in 0.997 plus, over here on our calculator, we're going to do 0.997 plus 0.0015. Our mean is going to be 0. Our standard deviation is going to be 1. Now, if you have this option, as you do on my calculator, I would leave it the way that you're taught it. So everything to the left, the tail to the left. And we're going to paste and press enter. So the z-score that we find for, the critical value that we find to construct a confidence interval with level 99.7 is going to be 2.9677, depending on how many decimals your problem asks for. 2.9677. 7. Now we can do this exact same thing with our second part here. Find the critical value z alpha over 2 needed to construct a confidence interval with the level 83%. So we're going to do the same process. The first thing I want to remember is my mean is going to be equal to 0. My standard deviation is equal to 1. I am trying to find this specific z-score or critical value right here. So I need to find this missing area first. So we're going to have 1 minus 0.83. And again, we have two areas that are missing. We're going to divide it by 2. Alright, so over on our calculator, we're going to do 1 minus 0.83. And then we're going to divide that by 2 to get 0.085. So this question mark area over here is going to be 0.085. So it is a good thing to remind you that this 0.085 is also the area that's found right here. I specifically don't like to write that area to the right because I am concerned with the area to the left. So I don't like to write that area to the right because sometimes it can get confusing and you have too many numbers on your page. So again, to find this critical value, we're going to use our inverse norm command in our calculator. Again, you're going to go second vars, and it's going to be number 3. So second vars, toggle down to number 3 and press enter. So we're going to clear that out, and now the area that we're going to be doing is 0.83, and I'm now going to add 0.085. And again, my mean and my standard deviation are 0 and 1 because I'm dealing with a standard normal curve. Excuse me, 0.83 plus 0.085, 0 and 1. Again, my tail is to my left. Press paste and enter one more time, and we find that our critical value is equal to 1.3722.